good evening everyone. Just confirm me once whether my voice is audible or not. Audio video is clear. Just confirm me once. Audio video is clear to you? Okay. Thank you so much. So again, a very good evening everyone. I welcome you all to the YouTube platform of IMS GATE Academy. We are running with a series of most excellent questions that are expected in GATE 2024. Today itself we got this beautiful news that ISC Bangalore has launched the website for GATE 2024. So you can also check the website regarding how many papers you can give for GATE 2024. If you are a civil engineering aspirant, you can appear for environmental engineering as a separate paper, geomatics as a separate paper. So all those combinations you can check, right? So GATE notification is out from 24th of August. You are allowed to fill the form and till 24th of September, last date is there for filling up the registration form, right? So I will suggest you, so along with civil engineering, please fill up the form for environmental engineering as well. Because this subject of environmental engineering gives you an equal opportunity to get selected for masters in IITs and NITs. Most of the PSUs are also coming up with this special post for environmental engineers. So there also you can get this benefit through the exam of environmental engineering. Okay. So let's begin this beautiful session for the topic of water demand and population forecasting. We will going to see the previous year GATE questions that are asked from this topic, and we will also going to see few concepts from which the questions can be framed, and we will going to see these concepts through questions only. Okay. Till date, not many questions are asked in GATE examination from this topic, but again, there is a wide possibility that, there's a huge possibility that the questions can be framed, and very easy, simple questions can be framed from this topic of water demand and population forecasting. So let's begin this session. I want you to first of all attempt the question. I'll give you sufficient time, and then we will going to solve these questions together. Okay. So this is the first question for you. Just read this question. This is the question from fluctuation in water demand. Question says that find the percentage ratio of maximum demand to average demand for the duration of 4 months. I'll just keep my timer here so that you can answer it accordingly. Okay, please attempt this question quickly. Please attempt this question quickly. So I want the percentage ratio of maximum demand to average demand for the duration of 4 months, right? Duration is given as 4 months. It's a very simple question. One simple equation is used to solve this question. Please answer it quickly. I'm quickly waiting for your answer. Just answer it quickly. So let's start with this. By Goodrich's equation, we get the percentage ratio of maximum demand to average demand. Percentage ratio of maximum demand to average demand. We get the percentage ratio of maximum demand to average demand. And can anybody tell me what is this percentage ratio? How you calculate this? Sir, I am in second year. I don't know about this. Don't worry, you will know about this in just 5 seconds after this, right? So the percentage ratio of maximum demand to average demand is calculated using the Goodrich's equation. And this Goodrich's equation is equal to 180 into t raised power minus 0.1. This is my Goodrich's equation. This Goodrich's equation will give the percentage ratio of maximum demand to average demand, which is equals to 180 into t raised power minus 0.1. Here t is the time in days. T is time in days. Here T is time in days, and the only condition with this equation is T should be greater than or equal to 1 day. So basically this Goodrich equation is used to calculate the fluctuation in water demand. That is, by how much amount the maximum demand is more than the average demand. Now depending on different durations like daily, weekly, monthly, like that, depending on different durations, you have different percentage ratio of maximum demand to average demand. Here we are asked to calculate the percentage ratio in maximum demand to average demand for the duration of 4 months, right? So if I talk about 4 months, how many days we have in 4 months? How many days we have in 4 months? Say for 1 month you are counting only 30 days. Can you tell me what is the time in days if you are counting 4 months? In 1 month, 30 days. 4 months, how many days? Quickly, 4 months, how many days? So 1 month is 30 days, 4 months is like 120 days. So here time to be taken is 120 days, right? Now just substitute T there, so you will get the percentage ratio of maximum demand to average demand. You will get the percentage ratio of maximum demand to average demand. This is equal to 180. T is equal to 120. So 120 raised to power minus 0.1. Calculate this, you will get the direct answer in days, right? In percentage. Please calculate this and tell me. Please calculate this and tell me 180 into 120 raised to power minus 0.1. So this will going to give you the direct percentage ratio of maximum demand to average demand. Please get me the answer for this. 180 into 120 raised to power minus 0.1. Please tell me the answer for this. Okay, so this is 111.52%. So percentage ratio of maximum demand to average demand for the duration of 4 months. This is for the duration of 4 months. This comes out to be 111.52%. Now, how we see this 111.52%? From this, we can write maximum demand for 4 months. Maximum demand for 4 months. Maximum demand for 4 months is equal to 111.52% of average demand for 4 months. So this 111.52% can be written as 1.1152 times of average demand for 4 months. Average demand for 4 months, right? So maximum demand for 4 months, is equal to 111.52 times of average demand for 4 months. So this 111.52 is nothing but the fluctuation in water demand for 4 months, for the duration of 4 months. This is the fluctuation in water demand when the duration is 4 months. Okay. So this is the first question. One of the simple question, again can be asked as a 1 mark question. When we talk about GATE exam, it is very simple. If the question contains one formula or one concept, it's a 1 mark question. If you have a question which contains two formula or two concepts, it will be a 2 mark question. Chalo, moving on with this, try this one. This is the next question. So you have this timer is there, right? So you have a timer for this 1 minute. Just attempt this question. Let's see who can answer this quickly. No idea. Okay, no problem. Okay. Let's try this one. It says that which of the following statement is incorrect? Statement A says that type of sewerage system affects the domestic demand. So basically these statements are from the factors affecting water demand. So let us see these factors one by one. First one is factors affecting water demand. Factors affecting water demand. Factors affecting water demand. So first one is type of sewerage system or type of flushing system. Type of sewerage system or type of flushing system, right? Now we know that if you have an efficient flushing system, then the amount of water required in the toilets will be less. It means that if your flushing system is efficient, your domestic demand will be less. Means type of sewerage system directly affects the domestic demand of water. This type of sewerage system affects domestic demand of water. Affects domestic demand of water. The next factor which affects the water demand is the extent of industrialization. Extent of industrialization. So this we already know. If more number of industries are present in the community, then more amount of water will be required for industrial use. So if extent of industrialization is more will be your industrial demand. So this extent of industrialization, it affects industrial demand. It affects industrial demand, right? The next factor is your climatic condition. Third one is climatic condition. Third one is your climatic condition. So if the climatic conditions are hot, especially during summer seasons, we feel like bathing twice or thrice in a day, right? More water we consume for drinking purpose. So if climatic conditions are hot, again it affects the domestic demand of water. So this climatic condition, it also affects the domestic demand. It affects domestic demand. It affects domestic demand. Then you have type of gentry. Type of gentry means if the living standards of the people are high, due to this high living standard, they consume more amount of water for domestic purposes. They will going to have huge houses, they will going to have huge gardens, right? Many people used to stay, variety of food is prepared. So if living standards of the people are high, it means more amount of water is required for the domestic purposes. So again, this type of gentry, again it affects the domestic demand. It affects domestic demand. It affects domestic demand. Okay. Next factor which affects the domestic demand is the size of the city. Is the size of the city. So basically, if the size of the city is more amount of water is required for road cleaning purposes, more amount of water is required by the public gardens. Okay. So if the size of the city is more, water for public use will be more. Okay. So the size of the city, it affects water for public use. It affects water for public use. It affects water for public use, right? So these are the top 5 factors. Now coming to the next factor, which is known as quality of water. Quality of water and cost of water. And cost of water. So basically, you can understand it like this. For example, if you have a room in which one AC is required to cool that room, that is your demand. But out of luxury, you have kept 3 ACs in that room for cooling. So that is what is called as consumption. Okay. When quality of water and cost of water, for example, quality of water is poor, even you are feeling thirsty, you will not consume water because it is dirty. Quality is poor. On the other hand, same happens with the cost of water. If cost of water is more, again the consumptions become less. Demand is still the same. So for quality of water and cost of water, it affects the consumption. It affects the consumption. It affects the consumption, right? It directly does not affect the water demand. It only affects the consumption. It affects the consumption, okay? So what we say that quality of water and cost of water, they indirectly affect the water demand. They indirectly affect the water demand. So quality of water and cost of water, they indirectly affect the water demand. Last factor is pressure in the distribution system. Pressure in distribution system. So if pressure in the distribution system will be more, there will be more leakages, there will be more losses. So pressure in the distribution system, it affects the losses of water. So it affects losses. It affects losses of water. It affects the loss of water, right? So these are the 8 factors which are affecting the water demand. First one is type of sewerage system. It affects the domestic demand. Next is extent of industrialization, it affects the industrial demand. Climatic condition, it affects the domestic demand. Type of gentry, again it affects the domestic demand. Size of the city, it affects water for public use. Next is cost of water and quality of water, they indirectly affect the water demand because they affect the consumption. Last one is pressure in the distribution system, it affects the losses. Now coming to this question, just observe the statements. You need to identify which of the following statement is incorrect. Statement A says that type of sewerage system affects the domestic demand. So this statement is correct, absolutely correct. Second, water for public use affects the water demand. No, this statement is absolutely incorrect. So we need to identify these statements. So this statement is absolutely incorrect. Then cost of water affects the domestic demand. No, my dear, cost of water indirectly affects the water demand, right? So this statement is also incorrect. Pressure in the distribution system affects the losses. So yes, this statement is correct. So for this question, option B and option C are the correct options. Option B and option C are the correct option for this, right? Because you need to identify the incorrect statement. So I hope you have understood this explanation. Moving on with this, just try this one. Again, I'll give you 1 minute time to solve this. Just try this one. It's a very easy question. Just try this one. Okay. So this question says that what is the ratio of fire demand by Buston's formula and the Cutchling's formula for the population of 2,30,000? So first of all, I write population of the community. Population is given as 2,30,000. This is the population, right? Now you need to solve this question by taking, first of all, by calculating the fire demand using Buston's formula, and then by Cutchling's formula, and then taking the ratio. So fire demand by Buston's formula is equal to fire demand by Buston's formula is equal to Q is equal to 5663 root P. Here the fire demand is calculated in terms of discharge in liter per minute, and P is the population of the community in thousands. P is population of community in thousands. P is the population of the community in thousands, right? So here the population is given as 2,30,000. So for this, the value of P will be 230. The value of P will be 230. The value of P will be 230 because population is 230,000. So P will be 230. Now just substitute this value of P in the Buston's formula. So Q is equals to 5663 under root P, which is 230. So from here you can calculate the fire demand using Buston's formula. Please get me this value quickly. Just solve this and get me the answer. Just solve this and get the answer. So this is 85883.65 liter per minute. So this is your fire demand using Buston's formula, Q. This is in liters per minute, right? Similarly, we need to calculate fire demand using Cutchling's formula. So fire demand using Cutchling's formula is equal to, so Cutchling's formula, fire demand using Cutchling's formula Q is equals to 3182 root P in liters per minute. And here also P is the population of the community in thousands. So here also P value is, so I'll write this, P is population in thousands. So you can substitute the value of P. So Q is equals to 3182 root over 230. So this is your population P in thousands, 230. Just calculate this and get me the answer for this. Just quickly get me the fire demand Q in liters per minute, which is 3182 root P, where P is 230. So this comes out to be 48257.42 liters per minute. Always keep a check on the units, right? Because whenever you have to take the ratio, both numerator and denominator should have the same unit. So this is the fire demand using Cutchling's formula, and earlier we have calculated fire demand using Boston's formula. Now you have to take the ratio for this. So fire demand by Boston's formula and using Cutchling's formula, this we have calculated, and this comes out to be, as per Boston's formula, it is 85883. This is 85883.65, and using Cutchling's formula it is 48257.42. Just get me the ratio for this. Please get me the ratio for this fire demand using Boston's formula and Cutchling's formula. So this ratio is 1.7796. So this is the ratio, right? So this is a kind of longer method for performing this question. This question can also be dealt directly. How I tell you, right? So this is the second method for solving this question, or shortcut. For solving this question using the shortcut, what you can do is, first of all, as per Boston's formula, fire demand is equal to 5663 root P in liters per minute. Okay? And as per Cutchling's formula, it is 3182 root P. So it's better if you directly take the ratio without calculating the fire demand individually, because this root P and this root P will going to cancel out. Both these root P will going to cancel out, and you will directly have the ratio of 5663 divided by 3182. So this is 5663 divided by 3182. So this again comes out to be 1.7796. So we can state that it doesn't matter whatever will be the population of the community. If it is asked to calculate the ratio of fire demand using Boston's formula and Cussling's formula, they can be directly calculated, because this root P and this root P will going to cancel out, and it will always come out to be 1.7796. Okay, so I hope you have understood this question. Chalo, moving on with this another question. Any doubt to anyone in this? Is this question clear to you? Any doubt to anyone in this question? Is it clear to you? Okay. Chalo, moving on with this, come to this question. Next, please attempt this one. Again, I'll give you a time for 1 minute because it's an easy question. Timer starts now. Please attempt this question. Let's see who solves this correctly. Okay, let's see this question. Question says that which of the following method is used to forecast population of an old city, right? You are asked which of the following method is used to forecast population of the old city. For the old city, we know that with the increase in population, the rate of growth of population decreases. Okay. So when I talk about different methods of population forecasting, you have arithmetic increase method, then you have geometric increase method, and then you have incremental increase method. Out of all these methods, arithmetic increase method gives the lowest value of population forecasted. Geometric increase method gives the highest value of population forecasted, and incremental increase method gives the intermediate value in between arithmetic increase method and geometric increase method. So when I talk about the old cities, arithmetic increase method is used to forecast population for the old cities because it gives the lowest value of population forecasted. Geometric increase method gives the highest value of population forecasted. Hence, geometric increase method is used to forecast population for young cities. This geometric increase method is used to forecast population for young cities. Okay. So for this question, your arithmetic increase method is the correct answer. Arithmetic increase method is used to forecast population for old cities, right? So I hope this question was easy. You have solved it correctly. Chalo, moving on to this. Again, this time I'll give you 2 minutes. Just solve this question. Your time starts now. Try and solve this question. Okay. So let's see this question. The population of the town is as follows. For the year 1980, the population is 42,000. 1990, population is 47. 2000, it is 54,000. And for the year 2010, it is 60,000. You need to forecast population for the year 2030 by arithmetic increase method, right? So again, this type of question can be asked as a 1-mark question in your GATE exam. Let us see how to solve this. So first of all, we will calculate the increase in population. Step 1 is calculate the increase in population. So here I'll write duration, then population, and then I calculate increase in population. So duration is 1980 to 2010. This is 1980, 1990, 2000 and 2010. Okay, then we have the population of the community. The population of the community is 42,000, then 47,000, then you have 54,000 and 60,000. So this is the population given to us. Step 1 for solving this question is find the increase in population x. So increase in population x. So this is x1. x1 is 47,000 minus 42,000. So this comes out to be 5,000. Next, x2. x2 is 54,000 minus 47,000. So this comes out to be 7,000. Next one is x3, which is 60,000 minus 54,000. So this comes out to be 6,000, right? Now you have to take the average value of x1, x2 and x3. That is the average increase in population, x bar. Get the value of x bar. So x bar is nothing but x1 plus x2 plus x3 divided by 3. So this is 5,000 plus 7,000 plus 6,000 divided by 3. So this is 5 plus 7, 12 plus 6, 18,000. 18,000 by 3 is 6,000. So from here the value of x bar comes out to be 6,000. The value of x bar comes out to be 6,000 like this, right? Now you need to forecast population for the year 2030. So first of all, this 2030 is how many decades away from 2010? This is the last known population, 60,000, corresponding to the year 2010. So this 2030 is 2 decades away from 2010, that is 20 years away. So the value of n is 2. 60,000 is the last known population P naught, okay. Using arithmetic increase method, Pn is equal to, or I'll write in the next slide, by arithmetic increase method. Population after n decades is equal to last known population plus n into x bar, okay. So we want population for the year 2030, which is 2 decades away from 2010. So P2 is equal to P naught plus 2 times of x bar. P naught is 60,000 plus 2 into x bar is 6,000. So from here we can calculate P2 is equal to 72,000. So this is the population for the year 2030, which is 2 decades away from 2010. So this is my population for the year 2030. This is my population for the year 2030, right? So 72,000 is the correct answer. This type of question can be asked in 1 mark or 2 marks, right? So this was a numerical answer type question that we have framed. So P2 comes out to be 72,000. I hope you have understood the proper method of solving any question through arithmetic increase method, right? Now come to the next question, this one. Try this one. Again, I'll start the timer. So your time starts now. Just attempt this question. Okay, now coming to this question, the question says that the past population data for a community is given below. So for the year 1970, the population is 45,000, 1980 it is 55,000, 1990 it is 85,000, and for the year 2000 it is 1,45,000. You need to forecast population for the year 2030 by geometric increase method. Okay. So again we will see this question. So first of all, I'll just write down the data. So in first column duration, then I have population, so duration is from 1970, 1980, 1990 and 2000. Population is given as 45,000. This is 45,000, then 55,000, then 85,000 and 1,45,000. So this is the data given to us, right? For solving this question using geometric increase method, step 1 is calculate percentage increase in population. Step 1 is calculate percentage increase in population. Calculate percentage increase in population. Denoted by R. Calculate percentage increase in population. So R1 is equal to 55,000 minus 45,000 divided by 45,000 into 100. Divided by 45,000 into 100. So this is the value of R1. I think this comes out to be 22.22%, right? Similarly, calculate R2. R2 is equal to 85,000 minus 55,000 divided by 55,000 into 100. So this is my R2. Just get me this answer quickly. So this is 54.54. So this is 54.54%. Next, calculate R3. So R3 is equal to 1,45,000 minus 85,000 divided by 85,000 into 100. So this is your R3. So this R3 is 70.58%. This is 70.58%. Once you have calculated the percentage increase in population, calculate the value of R bar by taking the geometric mean. So R bar is equal to cube root of R1 into R2 into R3. So this is the geometric mean for calculating R bar. So this is cube root of 22.22 multiplied by 54.54 into 70.58. So this is how you calculate the value of R bar, right? So this R bar comes out to be how much? This is 44.06. This R bar is 44.06%. This is your R bar, 44.06%, right? Now you need to forecast the population for the year 2030. And from the year 2000, this 2030 is 3 decades away. 1,45,000, this is my last known population P0. Then using geometric increase method, by geometric increase method, population after n decades Pn is equal to P0 into 1 plus R bar by 100 raised power n, right? So we want population for the year 2030, which is 3 decades away. So P3 is equal to P0, which is 1,45,000 into 1 plus R bar. So R bar is 44.06. So this is 44.06 divided by 100 raised to the power 3, because we want population for the year 2030. So when you calculate this, it comes out to be 433,509. This population for the year 2030 comes out to be 433,509. So this is my population for the year 2030. This is my population for the year 2030. Okay. So this is how you solve the question using geometric increase method. Okay. Now coming to the next question. I hope you have understood the solution. It was a simple question. Now try this one. In this question, you need to forecast population for the year 2030 by incremental increase method. You need to forecast the population by incremental increase method. Just try this question. The past population data is given to you. You need to forecast the population for the year 2030 by incremental increase method, right? So let's start with this. First is duration. Then you have population. So duration I have, duration is from 1970 to 1970, 1980, 1990, 2000. Then you have population, which is 28,000. Then it is 43,000. Then it is 53,000. And then it is 73,000. So this is the data given to us. When we solve this question using incremental increase method, step 1 is calculate increase in population. So step 1 is calculate increase in population. Increase in population. Increase in population, which is x. So x1 comes out to be 43,000 minus 28,000. This is x1. 43,000 minus 28,000. So this comes out to be 15,000. This comes out to be 15,000. Okay. Then calculate x2. x2 is 53,000 minus 43,000 minus 43,000. So this comes out to be 10,000. This is x2. Then x3. x3 is 73,000 minus 53,000. So this comes out to be 20,000. So x1, x2, x3 I have. Next step is calculation of x bar. So next step is calculate x bar. X bar is x1 plus x2 plus x3 divided by 3. So this is 15,000 plus 10,000 plus 20,000 divided by 3. So from here you can calculate the value of x bar, right? And this x bar comes out to be 15,000. X bar comes out to be 15,000. Next step is calculation of y bar, which is incremental increase. Next step is calculate incremental increase. Calculate incremental increase, which is y. So what is incremental increase? Incremental increase is y1 is equal to x2 minus x1. x2 is 10,000, x1 is 15,000. So x2 is 10,000, x1 is 15,000. So y1 comes out to be minus 5,000. This is the value of y1, which comes out to be minus 5,000. Next is calculate y2. y2 is x3 minus x1, x3 minus x2. So this is 20,000 minus 10,000. This is 20,000 minus 10,000. Okay. So this comes out to be 10,000. So from here, calculate the value of y bar. So y bar comes out to be minus 5,000 plus 10,000 divided by 2. Minus 5,000 plus 10,000 divided by 2. So from here the value of y bar comes out to be 2500. Y bar comes out to be 2500, right? You have the value of x bar, you have the value of y bar. You need to forecast population for the year 2030 using incremental increase method. So from 2000, 2030 is 3 decades away, and 73,000 is my last known population P naught. Okay. Then by incremental increase method, then by incremental increase method. Population after n decades is equal to P naught plus nx bar plus n into n plus 1 by 2 into y bar. This is the population after n decades, right? So we want population after 3 decades. So P3 is equal to P naught plus 3 times of x bar plus 3 into 4 by 2 into y bar. Okay. P naught is given to us. P naught we know. P naught is 73,000. So this is 73,000 plus 3 into x bar, which is 15,000. X bar is 15,000. Then you have 3 into 4 by 2 into y bar, which is 6,000. Sorry, y bar is 2,500. So after substituting all these values, the final answer that you will get comes out to be 1,33,000. So this is 1,33,000. So this is my final answer for the year 2030. So I hope you have understood the solution. So these are some of the basic questions that can be framed from water demand and population forecasting. Only these type of variety of questions you will find in GATE examination with respect to this. So I hope you have found this session useful. In the next session, we will continue with the excellent question set for the chemical water quality parameters and the physical water quality parameter, which is again one of the very important topic with respect to environmental engineering. So this is all for today. Myself Prateek Mishra signing off, and I'll see you in the next session. Thank you so much for watching.